Good afternoon, Algebra 2 Trig Honor students. So welcome back. So this one is for Day 2's lesson of trigonometry. So yesterday we talked about SOHCAHTOA and SOHCAHTOA, okay? So those are the abbreviations or the acronyms for recognizing the basic trig ratios. So now, for today's lesson, we'll talk about the way to apply the calculator or the scientific calculator or using the Google calculator to find out the trig ratios. Okay, so you'll see that in a minute. So we do have sine, cosine, cotangent, all those trig functions with the angles. And also we'll talk about the way to solve for the right triangles with the variables. And also we'll talk about some of the word problems, some of the basic application problem. Okay, so one thing at a time. So let's start with the basic trig ratio. So yesterday we talked about those basic ratios formula for SOHCAHTOA and SOHCAHTOA. Okay, so this one is use a calculator to evaluate the trigonometric functions. So round the solutions to the two decimal places. So sine of 37. So the way that you want to put it into the calculator, so then that will be considered sine of 37. So make sure that it's in degree, okay? If that's in radians, so that's going to come up with something else. If you try to put in radians, so that would be like sine of 37 radian. We'll talk about that, within the next two videos. So making sure that it's in degree. So sine, okay, so sine of 37 degrees, close parentheses. Here we go. So that one is 0.60181 or 0.60. Okay, so you just round it to two decimal places. If you try to do that in degree, then the solution would be a little bit different. So sine of, is that 36 degree or 36? Okay, so going back to the 37, excuse me. So sine of 37. So this time is going to come up with like a negative ratio. So radian, we'll get to that in the next two videos, okay? But again, stick that with degree. So sine of 37 degrees. So it's about 0.60. Okay, so approximation symbol, so 0.60. And then cosine of 12, so just enter that cosine and then 12. Now, what about things that it's not given on the calculator? So the ratios such as what? Cotangent, cosecant. So what should we do? Well, since we do know that cotangent is considered the reciprocals of tangent, so that means on the calculator we want to put in 1 over tangent of 48. Okay, or 1 divided by tangent of 48. Okay, so now to look at that, 1 over 1 divided by tangent of 48. Okay, so the ratio is about 0.90. 0.90. And what about for cosecant? We do know that cosecant, it's the reciprocals of sine. So that means 1 over sine of 7 degrees. Okay, so it's 1 over sine of 7 degrees. So clear. So 1 divided by sine of 7 degrees. Okay, so let's find out what that is. So it's 8.21. So this one we need to round it up. So 8.21. And then secant, again, this one is not given on the calculator. We do know that secant is the reciprocals of cosine. So it's 1 over cosine of 97. So on the calculator, so typing that 1 over cosine of, clear all this. So 1 divided by cosine of 97. So it's a negative radian. Okay, we'll talk about the reason why it's positive, negative in the future video. So 97, that passed through the 90-degree line. So that's why it goes to in the second quadrant. So for that ratio, it's considered negative. So 8.2, negative 8.2. Or negative 8.21. Okay, so negative, again, it's about. Okay, so for the rest of those, cosine of 12, tangent of 28, so simply just follow through the same trend right here, cosine of 12. So typing cosine and then 12 tangent of 28. Okay, so now for the next part, so this one, find the value of each variable, round the solutions to the 2 decimal places. So we do know that's a special right triangle here. Well, how do I know? Because this one is 45, 90, so that means the third angle, it's also 45. But somehow we still need to using a calculator for this. And for those students might be wondering, well, we can use this ratio of the special right triangle. Yeah, indeed, we can do that. But so far, since we need to round it, so we're going to apply calculator for this. So anytime that you're using the calculator, you still need to show me the way you set up the equation. Okay? So as you do know this, 45, that's the base angle. So 13 would be the adjacent. X would be the opposite here. And then Y would be considered the hypotenuse. So let's give some label for those elements. So start finding that X right here. So we're using opposite adjacent. So the ratio regarding opposite adjacent, then that will be considered tangent. So tangent of 45 degree. So that equals X over 13. And then this one is just like proportionality. So X, so that equals 13 times tangent of 45. So basically we can just cross multiply. Or simply multiply both sides by 13. And then for the rest of that, you can just put it into the calculator. So X, what is that about? So 13 times tangent of 45 degrees. Okay, so back to the Google calculator. So 13 times tangent of 45 degrees. Again, making sure that the unit, it's in degree, not radian. So tangent of 45, that's just 1. So 1 times 13, then that'd be 13. Okay, so this one is the same as what? 13. Okay, so 45, 45, 90. So this one, if that's the same measure of the angle, so that means this side here, it's also considered 45. I mean, 13, excuse me. It's the same segments. Isosceles right triangle. So this one, there's no need to round it. You can just stay that as exactly 13. So rounding, that means sometimes you come up with the irrational number. So things that's considered the non-terminating decimals or the decimal with the bar, then you have to round it. Either you round it up or you just keep it with the same decimal. Okay, so now the next one, another special right triangle, 30, 60, 90. Okay, so this one's 30. But this time, 60, that would be the given base angle. So that means X would be the adjacent because it's right next to the base angle. Opposite, which is what? 4. Because that base angle is 60. And then Y, which is the hypotenuse. Oh, you know what? Back to the previous one. We still need to solve for the other variable, the hypotenuse. So for those you might be wondering, the ratios for the hypotenuse would be considered root 2. So we can multiply the adjacent by root 2. Yes, certainly we can do that. But if you try to use that, the SOHCAHTOA, so hypotenuse and adjacent, so that means we're using cosine. So cosine of 45 degree. Again, going back to part A. So cosine of 45 degree, then that'll be considered adjacent over hypotenuse. So it's 13 over y. Again, cross multiply, so we do have y times cosine of 45 degree equals 13. So in other words, y equals 13 divided by cosine of 45 degrees. Again, so you want to approximate this one. So you want to put it into the calculator. So 13 divided by cosine of 45 degrees. Okay, like that. So that would be considered 18.38. Again, you want to round it to 2 decimal places. So 18.38. And now what about for this triangle? So similar. So this one we do have adjacent, opposite. So that means we're using tangent. So tangent of 60. So opposite over adjacent. So 4 over x. And then cross multiply. So you do have x times tangent of 60 equals 4. So in other words, tangent equals 4 over tangent of 60. And then you want to round it. Again, just do it on the calculator. And then for y, so for this one, it's the hypotenuse. So that means we're using opposite over hypotenuse. So the ratio for opposite over hypotenuse, then that'll be considered sine. So sine of 60 degrees, so it's 4 over y. And then y equals 4 divided by sine of 60 degrees. Again, you just want to approximate that on the calculator. Okay, so now let's see what else that we have for C. So it's quite similar. So this one is 30, 60, 90. So for those you might be wondering, what about if I try to use the special ratios? Can I solve for x and y? Certainly you can do that. So 30, which is the shortest legs. So since we do know that 30 degrees, 60 degree, 90 degree. And the ratio for those line segment, it's always considered 1x, root 3x. Instead of using x, so let's just put in the ratio. It's easier. So 1, root 3, and 2. So the one that's given already, it's the hypotenuse, which is the longest leg. So you want to set 2 equals 2 root 3 times y, or 2y. Because that's the shortest leg, it's 1y. Okay, so this one you can just say that 2y equals 2 root 3. And then solve for y, so that means y equals 2 root 3 over 2, which is root 3. So this one will be easier to do it. So let's say you don't want to round it, okay? And then what about the longer leg, which is root 3? So root 3, the ratio for that one. So then this one would be considered root 3 times y. Okay, so for x equals root 3 times y, then that'll be root 3 times root 3. Then that'll be 3. Okay, so again, hypotenuse is always twice as long as the adjacent. The shortest leg of the triangle, not the adjacent. This one is the shortest leg of the triangle. So let's put it this way. Hypotenuse, if that's a 30, 60, 90 degree triangle, so hypotenuse is always considered twice as long as the shortest leg of the 30 degree size right here. And then the longest size, so this one would be considered root 3 times the shortest leg. So we'll get into more about this in the later video. So for the other part of the video that we have in the future. But so far, just stick with the other method. So using the calculator. So using SOHCAHTOA, the ratios. So the way you can set it up for this one, alternate way, you can just start it off with, well, this one is adjacent. So adjacent over hypotenuse. So cosine of 30. So that equals x over 2 root 3. And then the other one here is opposite. So sine. So sine of 30. Then that'll be considered y over 2 root 3. Okay? So now, what about for those applications? So the shadow problem. So a person casts the shadow shown. Okay, so here we go. So what's the approximate height of that person? So we do know that this one, it created the angle 16 degrees. And the length for the shadow is 21 feet. And how tall is this person here? So this one, we do know that it's base angle. This one here is what? Adjacent. And we need to find out the opposite. So that means we're using tangent. So let's say opposite is y. So tangent of 16 degrees. So then that'll be y over 21. And then cross multiply. So y equals 21 times tangent of 16. Again, this one, you want to round it to, well, it doesn't say how many decimal places. So normally, if that doesn't say, so you want to round it to either 2 decimal places or 3 decimal places. So 21 times tangent of 16 degrees. 21 times tangent of 16 degrees. So that's about 6.02 or 6.022. And for those you might be wondering the unit, which is what? Feet. Okay? And sometimes you have to round it up to a whole number. If that's to the whole number, that means the person is what? It's about 6 feet tall. And here's the one for the mountain. It's about the altitude, elevation. Okay, so a hiker at the top of the mountain. So see a farm and the airport in the distance. So let's say that you go up to Mission Peak and you want to look it down. So you'll see a lot of the places from far away. So what's the distance d from the hiker to the farm? Okay, so this one, the distance from the hiker all the way to the farm. So there are a couple of variables that we need to solve here. So we do have y and d. Okay, so got to be careful with this. We do know the altitude of the mountain, which is what, 5,000 feet. Okay, to the peak. And looks like we need to solve for one of those variables first. So in order to solve for d, so we need to get the distance. So the distance of the mountain here, which is what, 5,000 feet. And while d here, obviously, is called the hypotenuse. Okay. And now, one thing that we need to come up here, it's the angle. Okay, so got to be careful with the way to come up the angle. So we do know that this one is 90 degrees. So this small angle here is 15. And this angle here is 29 degrees. So in order to get the measure of this angle, so let's say that this one would be the base angle. So what would you do? So going back to geometry, so let's say that we do have a rectangle. And there's a diagonal going through. So one is 15, the other one is, well, this angle here, it's 29, just in between these two line segments. So that one is 29. So 15 plus 29. So all together, so this one will be considered 44 degrees. Okay, so this one is 44 degrees. Okay, so the small angle and the angle right between these two line segments. So the sum of 15 and 29, which is 44 degrees. And now, one thing we notice from geometry, if two line segments are parallel, well, because that's a rectangle. So that means the upper segment, it's the same as the lower segment. So that means those two line segments, they're parallel. So using that, one of the postulates or theorem from geometry, so we do know that the alternate interior angles must be congruent. So that means this angle here, it's considered 44 degrees. Okay, so in order to find out the hypotenuse, so we're using opposite hypotenuse with the base angle. So that means the ratio will be what? Sine. So sine of 44 degrees. So then that will be considered 5,000 over the hypotenuse, d. And then swap those terms. So we do have d equals 5,000 divided by sine of 44. And then using the calculator, you'll find out exactly what that is. So 5,000 divided by sine of 44 degrees. Okay, so that would be about 7,198. 7,198. Now the things that you want to be a little bit more accurate, want to be a little bit more precise, so just round it up to 2 decimal places or 3 decimal places. So 7197, 78.782 or 0.783. But according to the problem here, so the height, it's given with the whole number, so it's better to round it up to a whole number for this type of word problem. So 7198. And what about the distance y from the farm to the airport? Okay, so the base distance here. So in order to get this distance, we need to get the distance from the base of the mountain to the farm. And also we need to get the distance from the base of the mountain to the airport. Okay, so got to be careful. We do have two different triangles here. Okay, so two different triangles. So in order to get that, the base distance here, so we can use, well, let's say this one is x. And let's say this one is z. So that means z equals what? X plus y. So y would be considered z minus x. So let's find out what x first. Okay, so what x is right here. So in order to get x, that means we're using tangent. So tangent of 44 degrees. So that equals 5,000 divided by x. Okay, so 5,000 divided by x. So now, and for the rest of this. So tangent of 44 equals 5,000 divided by x. So solve for x. So that means x equals 5,000 divided by tangent of 44. Okay, so just use that calculator later. And then the other one for z. So this whole triangle here. Okay, so we do know this angle here is 15 degrees. So in order to get this measurement, the bottom base angle here, from the top of the mountain all the way to the airport. So in order to get this base angle, we're using the alternate interior angle, 15 degrees. Okay, so 15 degrees. So then that'll be considered tangent as well. So tangent of 15 degrees. So that equals 5,000 divided by z. So that means z equals 5,000 divided by tangent of 15. So obviously this one is going to be bigger. It's going to be a bigger number because z is the longer distance. And also you can tell the denominator, you see that it's a smaller ratio. So that means you end up with a bigger number here. So eventually y equals 5,000 divided by tangent of 15 minus 5,000 divided by tangent of 44. Okay, so let's find out what that is on the calculator. So 5,000 divided by tangent of 15 degrees, close parentheses, minus also 5,000 divided by tangent of 44 degrees. Okay, here we go. So the distance right in between is 13,482. Or rounded up to a whole number, so 13,483. 13483. Unit feet. So the distance from the farm to the airport. All right. Okay, so now let's see what else. Okay, so day 3, we'll talk about the way to convert that in between degree to radian. So stay tuned. The other videos should be up there by tomorrow. The way to convert that in between degree and radians. So again, so you guys do like the video, so please subscribe to channels and also click the bell so in case that you're wondering about the new videos coming up. Okay, so thank you for watching it. I'll see you guys next time.